In this video, I'm going to work out the last two remaining problems from class section 3.1. This is going to feel like we're going to do the number again, and I think after 3.2, I know for me, after I did 3.2, as I was going through it as a student, 3.1, that kind of idea felt kind of weird to me, but here's a reminder of it. The definition in this section was if I wanted to find f prime of a, then that would be the limit as, we could do the h definition here, as h approaches 0, and we're going to do f of a plus h minus f of a, that's our y's, remember that's our slope, and then the over the x, which would be our change in x. So that would be our definition. So we just have to plug this in. This is one I'm definitely going to do off to the side. So 1 over, actually these just, yeah, let's do it here. Okay, 1 over h, 1 over, sorry, forgive me, a plus h, and let's go ahead and do a being 5. So 5 plus h plus 5, that is f of 5 plus h. Right, which is 1 over 10 plus h. Right, and then remember we would need to find the f of 5. We could go ahead and, I guess, plug that in. We'll do f of 5 plus h minus f of 5. Doing the top part now. Remember we did this in separate parts. So that's going to be 1 over 10 plus h minus, and then we just plug in 5 into the actual function, so that's 1 over 5 plus 5. Sorry for the weird 5 there. All right, so then that, we could go ahead and get a common denominator, or we could just leave it, I say we go ahead and get a common denominator. So that's 1 over 10 on the right there. So I'm going to put a 10 above here, and I got 10 plus h times 10 minus, and then I got that same thing here, 10 plus h times 10, but I'm multiplying this side by 10 plus h. All right, putting those together on top, I'm going to get 10 minus h all over 10 plus h times 10. Right, and then we're going to we get 0 from the 10s, those are going to be gone. And then we're going to minus h over, let's just leave that alone, and I'm not going to multiply it out until I know I have to. All right, so then I would take that whole thing and I would divide by h. That's our last step there. That over h. Well, I'm just going to do that here. You can see the h's are going to cancel out. So that's 10 plus h times 10 on the bottom, negative 1 on top. Okay, so that's what's going into my limit here. F prime of 5, that's our a, it's going to be equal to the limit as h approaches 0 of negative 1 over 10 plus h times 10. Right? We can plug that in now. If I do that, I'm going to get negative 1 over, if I put 0 there, it's going to be just 10 times 10, so negative 1/100th. That was A. B says determine an equation in the line tangent to the point with that plugged in. So for B, we want the point, like if I plug in 5, that's A, and then if I plug it in, I get 1/10. So there's my point. And then my slope for this would be the negative 1/100th, because that's what a derivative is. Woo, stumbling over words. And then, so I use my equation then, y minus y1 equals m times x minus x1. So 1 minus 1/10 equals negative 1/100th x minus 5. That would be B. All right, it gets messy, but most of the work was over here. You just have to make sure you can add fractions together using a common denominator method. All right, let's take a look at this problem, the last one for this section. I gave you guys this hint starting off, so this is where I'm going to start. We're multiplying by the conjugate. Right, so on the bottom, remember I don't multiply anything out until I know I have to, so I'm just going to leave it as a multiplication here. Plus the square root of 2. All right, so we have that. And then on top, remember that's a difference of squares, so I just multiply the first terms. I just get that, minus, and then I multiply the last terms, I got a 2. Right, and that makes the limit look much simpler. So I have h over h times the square root of 2 plus h plus the square root of 2. You can see that those h's are going to cancel. That leaves me, I still haven't taken my limit as h approaches 0 of 1 over the square root of 2 plus h plus the square root of 2. And the 0 would go there. I'd get 1 over the square root of 2 plus the square root of 2. That's my limit evaluated, and we like to simplify that. Just looks nicer. We don't have to rationalize, thankfully, but that looks much simpler than the one step before. That's it.